Hello, welcome to Econometrics Melody. This tutorial is about the graph types dot, matrix, and pi. This is our data set. Now let us see the first graph plot type. It's a dot, so it's similar to horizontal bar graph. So let us see how does it work. It is similar to bar graph and box graph. So we do the minimum of input over province. The province is represented on categorical x-axis, and these are the minimum values. Another one, graph dot minimum of input over province, and if you specify asyvar, now these categories of the province are treated as different yvar. This is evident by the difference in color and emergence of legend. Now if we specify as category, so let us prepare our basis graph for this, and we have specified two y variables, import and export. And if we specify as category, both the y variables are treated as the categories of a single variable, so we don't see any legend or difference in color. And if we specify percentage, first of all let us create the basis graph, and if we specify the percentage, then our y-axis, the denomination in y-axis are scaled to percentage, the respective percentage. So two different y variables, they sum up to 100% for each categories. Natural denomination, while the other is represented in percentage. And the options of dot graph is similar to that of bar graph and box graph. So for the detailed explanation of these options, please refer to the video number 4, bar graph. And let us go to the first options and let us explore some of them. Missing, nofill, and asyvar categories. We have dealt about yvar categories. First of all, let us create the basis graph for comparison. And if we specify missing, we will have the dot graph for missing observations as well, and we will see an extra categories over here. These values is for missing values. And if we specify nofill, the unnecessary categories that will be cleared out. So here we have the district for each province clearly sorted out. And if we specify is yvars, so different categories of a variable will be treated as a different yvars, so which is evident by the difference in colors. If we specify percentage, this is also a kind of repetition. First of all, let us create a basis graph for comparison. And if we specify percentage, our y scale is scaled to percentage. Now it's percentage. So for each categories, as we have a single variable, for each categories it is 100%. So the categories of the province or over variable will be treated as different yvars, and it is evident by the difference in colors. So the sum of these three categories now sum up to 100%. And if we specify percentage, two different variable y variables, and if it specifies percentage, so the two different y variables should add up to 100% for each category. So this should add up to 100% for north, and these two y vars should add up to 100% for their respective category. And if we specify two over variables, and asyvar and percentage, asyvar will treat is different yvars, so this is evident by the difference in colors. And again, for each category, the yvars should add up to 100%. Now let us go to the next option. It is outer gap, and it is evident by the term outer gap. So the gap of the labels from this origin and the outer part. Previously it was outer gap was 18, now the outer gap is 20. So if we combine it, this will be clear. The first one, outer gap, is 80, and we see this gap, and in the second one the outer gap was only 620. And let us manipulate the other feature. It's a line gap, and first of all let us create a basis graph for comparison, and we specify line gap to be 10, and so between these yvars, the line gap, there will be the line gap of 10, two line will emerge, and this is the line gap. And if we specify the term is categories, we'll get a similar result. Now let us manipulate the feel and look of the marker and the lines, so we can increase the size, color, and we can fill it. So let us see it by the help of example. What have we done here? We have taken the first marker, that is the marker of the first y variable should be represented by triangle, and the marker of the second y variable should be represented by solid circle, and its color is red, and so on. These are the styles. And let us try the other one and say it for ourselves. Again, 2y variable over province, marker first symbol is triangle but hollow. In this case, this is our first y variable representing 33 percentile of import, and second marker, its symbol is solid circle, red, size 3, line pattern. So this is the line pattern, and we have manipulated the line width 0.3, line pattern, line color is gold. So this is similar to an object-oriented programming. We get hold of the object and manipulate its style. Now let us sort the lines, and let us say this minimum of income, only one variable, over district, mark, and color. So this is the basis actually. And if we see by default, so the x categorical variable, it is in the order of A to Z. Now if we sort it, we are going to sort it in the descending form. So if we write only descending, then obviously we get the result from Z to A, from top to bottom. And if we write sort 1, for sort 1 here is treated as the sub option of over variable. So over is district, so the district will be sorted according to its ascending order, the value of. So if we see, this is in your increasing term. Now sorting according to the P30 of income, we have specified our basis for sorting is 30th percentile of import, and let's see. So at the initial stage, this graph may not seem as the sorted graph, but our basis is, it is due to the basis. The basis of sorting is 30th percentile of import, and let us see what is the 30th percentile of import, the order of the districts, and we'll match the order of the districts in both the graph. So this is a sorted graph. It's P30 of import, and this is the order of the districts, and once we combine it, we will see the difference, and we'll be able to compare it. So this is taking some time, and we have sorted the income, mean of income. By default, the statistics is mean. So mean of income is per the 30th percentile of import. So if we compare this order of the districts, they are similar. Similarly, if you want to sort it's or according to our preference of the district, then we can arrange them in this order and we can sort it. Now let us drop all the graphs and let's move to another plot type. It's a matrix graph, and matrix graph is also sometimes very useful. So all the interactions of the variables that we imply y variables, it draws the matrix graph. So income and import, so this block represents income and import, this block represents income and export, this block represents import and export, and this is the repetition actually. And if we specify, we can also manipulate its marker symbol, size, and color. So we have our triangle as the marker symbol, its scale is 1.5 and color is red. So the options that we can use for manipulating the matrix graph, and we will see some of them. So graph matrix, we are going to use half, so only the half portion, the lower half will be displayed, the upper half will be discarded. So we gather, and this a small marker is due to the point marker symbol. We have specified the marker symbol to be P stands for point. That is why we see this small fine dot. Now let us label the marker. So here we have M label is district, so the marker symbol, the small marker symbol, they will be labeled by the district name. And we have taken the marker symbol is O stands for solid circle and S stands for hollow, so we get a hollow circle, and each marker is labeled by the district, respective district. And we are going to change the name of the diagonal. This labels income, import and export by first good, and if we specify dot, the second one will not be changed, and the third one, this export, will be labeled by the name fine. So we get good, import and fine. Now let us label the X and Y and understand it by the help of example. So M symbol is triangle and hollow, so we get the triangle and hollow. Scale is 1.2, so 1.2 times we have scaled this marker symbols or marker. X label, so we have, this is our x-axis and this is our first x-axis, this is our second x-axis, and this is our third x-axis, so we can label it. Similarly for Y, this is our first y-axis, second y-axis and third y-axis, and the number of axes depends on the number of variables, y variables we specify. X label, so the first x-axis, its label is at the gap of 2500 all the way to 10,000, so this is our first x-axis at the gap of 25,000 all the way to 10,000. Similarly, x-axis third and x-axis second at the gap of 1500, this is x-axis second at the gap of 1500, third x-axis at the gap of 1500 as well, and all the way to 6,000. And similarly, we can interpret for the Y label as well. Labeling of x-axis, this is similar to the earlier one, and we can manipulate these labels according to our choice. In the x-axis, we see the labels, so they are in a different position, and I specify it is due to the specification of angle 90 degree. Had I specified marker symbol to be triangle, we would get bigger triangle or a smaller triangle. Capital T stands for bigger triangle, and a small t stands for a small triangle, and so on. These are the styles. So we can specify the styles according to our choice. And if I specify H, H stands for hollow, so a small triangle, and the triangle will be hollow, so it will not be filled by any color. Similarly, we can plot the matrix graph by certain variable, categorical variables, and we have a specified province. By province, we are going to plot this matrix graph, and this is the result. This is all about matrix graph. Now let us move to other plot type, pie chart. And pie chart, if we specify the y variables, so the y variables will contribute in forming a sector or slice. And import, income, import and export over province, we will specify only one variable, y variable income, but the pie chart should represent the sectors or slice each for the categories of this province. East, west and north. Similarly, if we specify, if we can label it by this option P label, and these are the options or styles or sub options, and we can manipulate the color. So we will label all by percentage. So let us see, we'll get a pie chart labeled. So all the sectors are labeled by the percentage. It's percentage, and the color should be white, size 1.8. Format of the number is 2 point, no decimal. After decimal, we don't have any digits, and it's a fixed format. Legend is on, and if we off the legend, we can always off the legend. And if we off the legend, we won't see the legend. It is as clear as anything. And this is title and subtitle. Now let us sort this slice either in ascending or descending order. So P label all the sectors or slice should be labeled by its percentage and color white. This for the same interpretation. And if we sort it, we will see the slices in terms of their ascending order, beginning from 12 o'clock position. So 5 for 12 o'clock position of the clock. So 5. So if you see, they are in their ascending form. So the first graph is an unsorted graph. The second graph is the sorted graph. This is the pie chart of over district by province. So the districts of each province will be represented in a pie chart. Let us draw them all. And these are the options of pie charts. We can use it according to our convenience, and these are very simple. And probably we have used some of them. Now let us label the pie sector of the pie chart, and we can call the sector name. So, and we have labeled used p label, so all the sectors should represent their sum, and these are the positions for y and x. It should have this label missing. This we are using the text. So the labels of the text in the white color, these are the result after text, and these are the coordinates y and x position. Just again repeat the same process. P label, we are calling the slice number 1 2 3 4, and for the first slice we want to display the sums. For the second slice percentage, for the third sum name of the categories, and for the fourth slice we are going to replace it by miss. So this is the sum. This is the percentage name of the category. It's a north, and we have replaced this by miss. Similarly, we are going to use this explode feature. We're going to call the pie, that is the slice, and we are going to add this sub options or styles. So slice number 1 and 2 should explode, and its color should be this RGB format, red color, and so on. Pie 3 should explode but color can, and so on. This is different. Pie 1 and 2, it explodes with color this. Pie 3 color can, pie 4 color gold, and the line colors is green, and line width is very thin. The line width is very thin, and if we specify very thin, if we specify thin or huge or large according to let us write thick, so we can manipulate these styles. So this is the difference. Now let us sort it. Use this option called sort. So all percentage and sort. This is a sorted pie chart, which is a kind of repetition. It's a kind of repetition. And if we want to sort the slice according to our preferences, then we'll have to specify our preferences. So I've generated rank 1. I want to sort this pie chart according to this districts F, G, H, K, A, B, C, D. So let me prepare a variable. So I have generated a variable called rank, and I'm going to sort this according to the variable rank that I've already specified. Let me use this once again. Let us combine and compare it, and we will see it for ourselves. This is a sorted graph according to these preferences. So this is the default one, sorted graph. And if we see the legend, the name of the variables or the name of the district follows this pattern: F, G, H, K, F, G, H, K, A, B, C, D. Now let us use the buy option, and by now it is clear. So we're going to draw a pie chart according to this option. So we have drawn a pie chart according to the education, undergraduate, and graduates. So if we off the legend, you'll get a bigger pie chart without the widget. This is all about pie chart. So we have covered 3 different plot types over here: dot, matrix, and pie. So thank you very much for your time. Thank you very much, Econometrics Melody.